So this is going to be the 4.4 video for in class talking about corresponding parts being congruent triangles. So we're going to state why the two triangles are congruent, write the congruent statement, and list all of the other corresponding parts to it. So first, why are the two triangles congruent? Right now I only have two things that are congruent, so I need to make something else congruent. So it looks like we have vertical angles. So I could say for A, angle JKH, because you can't just say K because I don't know which part you're talking about. K has to sit in the middle because it's my vertex, is congruent to angle LKH by vertical angles. Okay, so then B, we're trying to state that the two triangles are congruent. So triangle JKL is congruent to triangle LKM. And why are they congruent? Well, angle, angle, side. Okay, so we go angle, angle, side. That's why it's angle, angle, side. I'm going to erase those to do C. Ooh, whoa. Okay, so to do C, we have to list all the corresponding parts that are congruent. So angle J is congruent to angle L. Angle M is congruent to angle H. Angle K is congruent to angle K. And then sides, JH is congruent to ML. KL is congruent to JK. And what do we have left? KH is congruent to MK. So all the parts that are corresponding that are congruent. Because once we prove that the two triangles are congruent, that means all of those corresponding angles are congruent and all those corresponding sides are congruent. Okay, what are the values of x and y? Okay, so we see these two sides are congruent. If they're congruent, it means they're the same, which means we can set them equal to each other. So I have 2x plus 1 equals x plus 3. Let's go ahead and solve. So I have x equals 2, but I still need to find y. So these two sides are equal to each other. So we can set those equal to each other. But I found what x is, so wherever I see an x, I'm going to replace it and put a 2. So now I have 2 plus y equals 6 minus 3y. Move some things around, so I'm going to get 4y equals 4, divide by 4. So y equals 1. Okay, I could have asked what the missing sides were, so just make sure you're looking to see what I'm asking for. But right now it only wants you to solve for x and y. Okay, fill in the statements in the arrows for the flow proof. So my first one is a given statement, so let's just put QS is parallel to RT. My next one's a given statement, so angle R is congruent to angle S. So let's go from that to that. Then let's go to the reflexive property, because we know that if they share the same thing, so QT should be congruent to QT because they share the same side and it looks like they're the same. Okay, so we can say by the reflexive property, QT is congruent to QT. Okay, so now I have an angle and a side. I need one more thing to prove my triangle is congruent. So it looks like we have parallel lines. So if I have parallel lines by those arrows, I can use alternate interior angles. But here's the deal. I got to have it included in the correct spot. Okay? So let's mark our alternate interior angles here. So we got this one and this one. And that one and that one. Okay, so I want the one that's included in that side. Okay, so it looks like I could do angle, side, angle if I use the brown. Or if I use the gray, I could do angle, angle, side. Well, I need to do angle, angle, side. So it looks like I need to do the gray version. So you got to look to see what the next step is to be able to do it. So if I'm doing angle, angle, side, I have my angle, and my side. So I need the gray ones. So this is going to be angle STQ is congruent to my other gray angle. So R, angle R, Q, RQT. That's supposed to be a Q. So angle RQT is right there. Okay, because it makes my alternate interior angles and it gives me that angle side that I need. Okay, so now since I proved angle side and I have three things being congruent, I can say my two triangles are congruent. So triangle, let's say this one first, so STQ, STQ is congruent to triangle, match them up, so the S is congruent to R, T is congruent to Q, and then we have their Q being congruent to T. Okay, so now by CPC we can prove what we're trying to prove. So since we proved those two triangles are congruent, that means all of the corresponding angles are congruent and all the corresponding sides. So we know angle QTS is going to be congruent to angle TQR. So it's basically the same proofs. Like we're proving the two triangles congruent, we're just adding on, like, hey, prove these two angles are congruent by proving the two triangles are congruent. So you just state this at the end because that's what you're trying to prove. Okay, so number one is given, so let's put our given in here. Okay, number two, MO is congruent to MO. If they're the same thing, so here's MO, it's the reflexive property of congruence. And then, so we proved that, and now we can prove, it looks like we have three sides are congruent. So we could say side, 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 and say those two triangles are congruent. So triangle MPO is congruent to triangle MNO by side, side, side. And now, since the triangles are congruent, that means corresponding angles are congruent. So angle N should be congruent to angle P by CPC. Okay. One, two, three, four, five. Okay, so we always start with our given. So QK is congruent to QA, and QB bisects it. I don't have enough space, so I'm just going to put an arrow. By given. Okay. So we have something bisecting something. It looks like they're sharing this side. So if they share that side, we could say QB is congruent to QB by the reflexive property. Okay, and it looks like now we have three things that are congruent. So it looks like side, angle, side. So SAS, we can say the two triangles are congruent. So triangle KQB is congruent to triangle AQB. Ooh. By side, angle, side. So now, since the two triangles were proven congruent, we can prove that all of the matching corresponding angles are congruent and all the corresponding sides. So KB should be congruent to AB by CPC. Just an extra step you have to add.